So the 16 sum in lead code is 3 sum closest. So basically what we are trying to do here is it's exactly the almost same as the previous one. So basically what we used to do there was like we used to take the sum of the three and the result should be 0, correct? And we used to find all those similar triplets like which were constituting to the sum as 0, correct? Now what is the difference here is we'll have to just the change is the target was 0 there, but here the that target will be given. Okay, here it is says 1, and it can be it's a variable, it can be anything. Okay, so that is the one thing. So what we'll have to do is we'll have to find a triplets again. We'll have to take a sum of it, and we'll have to, we might not get the exact target this time, but what we should do is we should be picking the nearest sum. Okay, let's say that if I do any three sum, right, if I get a 2, if I get one at once, we'll get a 3. Okay, and let's say that if I do the one sum again, I might get a for another combination I might get a 6 5, right? What is the closest one among 3 6 7, whatever the result we get, right? Obviously 3 is the closest one. We should be returning the 3 in that case. Okay, so that is what the problem is about. And coming to implementation, it's almost same as the previous one. Same algorithm, like we'll be using the two pointer method here. Okay, so coming back to here, right, initially, like let's say that like usually when we start our program, it will be result will be 0, or we'll set it like that, right? So here it should be infinite because we don't know, right? We are trying to find the minimum one. If we say it is a result is 0, that is the final result, correct? That is like a, we have reached the target, that's what it means, like, right? When you say result is 0, it means that I mean that is the final value. I mean that is that is the thing, like, I mean, uh, yeah, let's say that, okay, that's not exactly that, like, okay, let's say that we will take a three numbers, okay, 1 2 3, and if I directly say that it is a 0, and I'm like, I'm assuming that the nearest number possible, that is not correct, right? We should be keeping our assumption to be for like almost like a false assumption, right? We'll have to make a false assumption. The false assumption is result itself is infinite, that is the number we will be getting at the end. Okay, that's why it will be, we'll be assuming it as an infinite. Okay, and now coming to the implementation, it's almost every time it's exactly same as before. We will be keeping our, while taking a threesome, we will assume this will fix one number, that is the initial number, and we will be finding out the rest of the two, like again iteration, right? We will using this will be this will be fixed, and we will be using trying the combination using left and right pointer from here. Okay, for the explanation we can watch the previous video, but to get just to give an overview, as we have kept that one pointer, right, we can find the, we can using left and right pointer, we can take a we can find the second and third number. We'll take a sum, and we'll try to find the difference between the target, like whatever the difference we, what is the difference we have, right? And also we are taking absolute of it because we don't care about the sign here, because let's say that if the target is greater than sum, or if the target is less than sum, at the end what it matters is let's say if you do target minus current sum, right, we might get positive, we might get negative. At the end what we need is what is the difference between it, right? Like we don't care about the sign, so it will be absolute always, like, okay, this is like whatever the, what is the difference between the current sum, what is the difference between the previous sum, and finally if the if you are, if this is the closest, right, current sum, if the current sum is having the least difference, we'll be taking it. Okay, and also if it is exactly same as target, right, we'll just return it, we'll stop the flow here, we don't have to proceed further. Okay, and let's say that if it is less than the target, it means that we need to add few numbers, right? So that's why what we'll do is we'll increment the left pointer, and this relies on this sorting actually, like as we know that it is in sorted order, we know that if we increment, obviously we'll get a higher number than the previous one. Let's say that if my pointer is setting to 12, right, if I add 1 to it, I can go to 13. Like let's say that if the next number is some 2, okay, so it will go, it will reach me to, it will add the sum to 14, which is closer to 16, correct? 16 is the target, 2 is the, like I am getting the only two difference. If I increment one more time, I might go to 15. If I increment one more time, I might exactly go to 16 or behind that. That is up to the that is dependent on the whatever the numbers we get in the iteration. Okay, at least what we understand is, like if the number is less than the target, we'll have to increment it, whatever the sum, right? To increase to reach to the target, we'll have to increment it. Similarly when we are coming from the other end, right side, as we know, as we to repeat again, like I mean it will be the, as we listed is sorted, right? So now let's say that target is 16, but we are getting a result as 20. What do we do? Like we need to get those numbers which is which will make a sum closer to the 16. So basically we'll have to reduce one number, right? So what we'll do is we'll decrease the right side pointer now, keeping left side constant. We'll decrease the right side pointer. Now what will happen? So 5 plus 6 plus 7 initially. Now we might decrease our pointer, right? We might get the number less than 7. So now after taking a sum, it might give us the result of 18, which is nearly closer to 16. And again, if I decrement that, I might get 17, or I might get exactly 16, or I might get less than, I might go less than 15, less than 16 also. But what is helping here, like the result, as a result we are getting beyond 16. If we decrement our right side pointer, we will be going closer to our result. So that's why we'll have to decrement our right pointer when the current sum is greater than the target. If the current sum is less than the target, we'll have to increment our left pointer. That is it. This is the logic. This is just to skip the duplicates. We have this thing, like, I mean, if it is 1 1, we don't have to duplicate or run our things again. Look, we'll just a duplicate part. Yeah, that's it. Thanks.